Hello, we are talking about functions. This is chapter 5. Now, if you are familiar with any programming language at all, you know how important functions are. I mean, many of the programming languages have functions. I should not say all of them do. And it's gonna take a while to get used to it and to begin to appreciate all the theory that I'm going to talk about right now. Have some patience. It may look to you right now that it's going to be something useless. It's going to be all these strange words about local variables and global variables. By the time you are doing a final project, you need to be comfortable with those terms. Essentially, after this chapter, if you understand this chapter well, you would be ready to start a project. Okay, let us say what is functions. So we will talk about two types of functions, void functions and value returning functions. We will design programs using functions, and we will talk about local variables, global variables, and passing arguments to function parameters. There is a distinction between parameters and arguments. And just to speak about the meaning of this, we will use functions to modularize the code. Later, we introduce value returning functions. I'm not going to talk about them in this video. And then we will create our own value returning functions. And this is something that you do very, very often in programming. We will talk about two packages, random package and math package. Random will be much more used than the math package in our class, but both are definitely useful. And finally, we will store functions in a separate file called module, and we'll find out how to call them from that file. All right, so this is a group of statements within a program that performs a specific task. Usually, one task in a large program don't try to stuff too much into a single function. It is helpful to modularize a program that is a bunch of some of the code can be encapsulated inside a function and can be called in the main line logic of the program by just one line referencing this function. So compare these two programs. One is a long sequence of statements and another is a sequence of functions, each of which performs a few statements. So this is much more readable and, more importantly, much easier to debug. Of course, this is an ideal situation. You cannot always do such grouping by three at a time or by so many at a time. On the other hand, know this: if you wrote a function, you should debug and test it separately before you write the next one and before you do the main logic. Or maybe you like to do a top-down approach and you start with the main logic being where you split the main problem, or you begin splitting your algorithm into smaller tasks, and each function will perform such task. So benefits: simpler code, reusing code, functions can be called with various arguments, easier testing and debugging, you should debug each function separately, faster development, and also you are able to delegate tasks to different people, and if you give them a description of a function you need, they will be able to write it for you. For now, we are doing void functions throughout this video. I will say that it's a function that executes statements. It can be a print statement. In fact, print will be our first void function. Even though it can print a bunch of things, it's not an output of a function. The only functions that are value returning are the ones that return values of variables. For example, when we used print, we just said print parentheses and something inside parentheses. As opposite to input function, input, we also had parentheses. Every function is supposed to have parentheses where the arguments go. And there we had a prompt. But the main thing is that before the input function, we had variable equals to then input whatever. That is because the result of an input function is stored in a variable for use later. So input, int, and float, for example, are value returning functions. Okay, function name in rules cannot use keywords as function name cannot contain spaces. First character must be a letter or underscore. All other characters must be letter, numbers, or underscores. Uppercase and lowercase are distinct. In general, function looks like this. Function name, parentheses, there may be a bunch of arguments inside, and then indented statements. Function name should be descriptive. It can include a verb, what does this function do, or a noun, or both. Well, function has a header, def function name. By the way, def comes from define or definition. We're defining a function name this with parameters inside the parentheses, and the function does whatever this indented statement block does. We need to be able to call a function to execute it, and whenever it's called, the interpreter jumps to that function and executes the statements in the block, and after it's done doing that, it returns to the point after the function call. Main is often used in projects and in programs to signify that this is a mainline logic of the program, and inside this main function, other functions are called as needed. So usually there is a main file, like main py, and inside this main py there is def main function, a few lines calling other functions, and then the function called main. We will see that. Well, blocks must be indented. If you do any exercises at all, you will need to do that. And you will get used to doing that and do that without noticing. So top-down design is a very important technique for breaking algorithm into functions. You have some idea of what you want to do. You can break it into high-level steps and then break it down even more and then define functions accordingly. We can look at the hierarchy chart, for example, the one here on the screen, and understand what it does. So main logic of the program, and I guess you read it from left to right: get input, calculate gross pay, calculate overtime, calculate withholdings, calculate net pay. So from just reading this, you can already tell what your function is doing. What your program is doing. The main function is for. And then each of these functions can be split or can contain actually two other functions. For example, get input will call get hours worked and get hourly rate. And calculate withholdings will call calculate taxes and calculate benefits. So not much details are included in here. For example, we're not including here the parameters that we need for the arguments that we are passing in this function, but that gives us actually a pretty good idea what the function does, because the names of the functions are nice and there is some structure substructure in input and calculate withholdings. So we have some insight on what the program actually is for. Without understanding local and global variables, it's kind of hard to use functions proficiently. Local variables are variables that are assigned a value inside a function, and only statements inside a function can access it. If you try to access from outside, there will be an error message. So very roughly, and it's not completely true, but what happens inside a function often stays inside a function unless you use one of the in-place methods that we are going to talk about later. The scope for the local variable is the function in which it is created. The outside program does not know about the value of that variable, or that variable exists at all. So different functions may have, this is important, may have local variables with the same name. They don't know about each other's variables, so that is completely fine. So maybe not a great practice to always use X, but sometimes there are definitely legitimate reasons to name variables in the same, give the same name to variables in different functions. Well, we need to first of all define what is an argument. Argument is the data that is sent into the function. Like in math, you are plugging a value into a function. So function can use arguments, and the argument is placed in the parentheses following the function name. For example, let's look at this. This is the main logic. In the main, we define value equals to 5, and then we call our custom function show double in parentheses value. So that is a top-down approach. First the main function, and we decided what the main function should do, and then we are going to worry about the show double. So that is a function that doubles the number. Result is number times 2, and we just print result. By the way, these functions are void functions. They are not value returning functions. All right. Let me talk about parameter. Parameter is a variable that is assigned a value when the function is called and is executed. So parameter is kind of closer to the mathematical notion of a variable. That's an unknown for which the formula is written. You can in some way think of a function as a formula depending on some mathematical variables. So scope for a parameter is where parameter is used, that is the function where it's used. Okay, so back to the previous program. Over here, the number in parentheses is a parameter, and value is an argument that is passed for the number. So number equals value. That is what's happening. The parameter number is assigned the value. Yes, you can pass multiple arguments and into a function, and one way to do that is pass them by position. So first parameter receives the value of the first argument, second parameter receives the value of the second argument. Okay, so this is a function with two arguments. First of all, main, print the sum of these two numbers, and then show sum is our custom function. Two arguments are passed into it for parameters num1 and num2. So num1 and num2 are parameters, and we pass values into them directly. 12 is num1, 45 is num2 as per position. This is, by the way, also void functions. Let me switch to idle and play with a couple of examples there. Let's start with a demo of a basic function, and let me restart the idle. So we define a function message, which is basically these two printing statements. And then we call the function from the program itself. So we can call a function from the program, we can call it from another function, and we can call it from idle. So here the function was compiled. This is now the function call message, and the interpreter jumps here and executes the function. Okay, another way to call a function, you can do it straight from idle after you ran this program, even if there was no function call over here. I'm going to close the idle again for clarity, and let's run this. Nothing will be, the program will be executed, so the Python ran through this function. Now it knows about this function, and I can call it from here, from idle. So I called my function from idle. It can be convenient if you want to check if it works for testing and debugging. All right, now let us play a little bit with variables. So this is another program. There is a main function and there is a change me function. And we want to see what happens when we change a value of a parameter. Let's understand the main function first. So value equals to 99, print the value is 99, then do execute change me function on this value, and then print back in the main the value is value. So we have tried to change the value of the function using this change me function. What does it do? Change me function argument, print I'm changing the value, old value was argument, the thing that was passed on, and now I'm changing it to 0. Now the value is argument. And let's call from the program itself, run. Let's work through this carefully. We called the main function, so Python jumped over here, value is 99, print the value is value. The value is 99. Now change me value. Python jumps over here, print I'm changing the value, the old value was 99. That is the argument that was passed in. Python changes it inside the change me function. Now the value is 0. And that's the printing statement that prints this line. So it changed to 0 inside the function. However, and that's the point of the exercise, it does not change the value outside of the function after we're done executing change me function. We can print and the value again, and the value is what it was before. So the value change that happened inside the function does not affect the value outside of the function. That is because local changes, local assignment does not matter to our global in the main value. Hope that makes sense, and hope that is something that you will keep track of when writing a program. And let us try another example with a global value. So we created a global variable, or in this case global constant, because it never changed over here, and we are calling, the only function we are calling is show value. Let's see what will happen when we do that. So the function, the global variable, global constant more precisely, is called from inside the function, and it returns a global value. So that's another little example, and you are probably a little bit bored with all these little examples and you want to see it being used for something. Here is one more interesting example. we are going to use Turtle to draw squares. Well, let's read through the main. That should tell us what the program does. Of course, we have to import Turtle in order to use it. We are hiding the turtle so that we don't see that little triangle running around. I guess we don't want that. And we are drawing 3 squares. So this is a custom function square, which is called 3 times with different parameters. And we are attempting to draw 3 squares, and there is color specification even. We need to understand what these parameters actually do. For that, we need to dive straight into the square function. So square function takes 4 parameters, 4 arguments. Parameters are x, y, width, and color, and arguments are 100, 0, 50, and red, in this case, which are passed for corresponding parameters. First of all, open up, that's just don't draw. You go to the appropriate XY coordinate, that's where you start filling with the color, and do pen down to start drawing, and begin fill. And now this is a little for loop, the thing from previous chapter that we all need to be very comfortable with. And what does this do? Turtle moves forward by value of width. The width is a argument that was passed into my function. For example, for this line, the width would be 50. I guess that's the side of the length of the square. And so we draw one side of the square, then we turn left, then we go back to the for loop. It repeats 4 times. So we draw 4 perpendicular, consecutively draw 4 segments perpendicular to previous one, and that way we draw a square. Okay, now let's run and see what this does and how it does it. Here is the first square, second square, third square. Well, if we'd like to slow down our turtle speed, we can do that and enjoy it for a little longer. So turtle speed 1, and rerun, see what we can have right now. So it kind of draws slower, goes through each of these little loops 4 times, and then fills in. And here we go, it is done. And notice, as previously, these functions definitely do something, and they are void functions. They don't return any values. That is something for the next video.